Hi everyone and welcome to this video, and I will say welcome to this Generative Adversarial Networks full course. As in the previous video of this course, we have talked about deep learning, the basics of deep learning that are required for Generative Adversarial Networks. In this video, I'm going to talk about GANs. I'm going to give you a brief introduction to GANs, what they are, how do they learn, etc. So I hope that you're excited for this video, and I'm too. And in the next video, we're going to make our first mega project, which is generation of fashion clothes. And I hope that you will enjoy. We will code it live. It's eventually maybe 30 to 40 minutes video, and it will be very worthwhile for watching that video. And I'll explaining each and every line of code. I'll be coding a live video, and I hope that you will enjoy the previous video, and I hope that you will also enjoy this video, because in this video you will actually going to get what are GANs. Okay, so what we are going to study in this video, we're going to talk about the overview of GANs, then we'll move further, then we'll talk about training process of GANs, then the training process of discriminator and the generator. Don't worry about this two terms just now, and then we'll talk about summary of training process, and then we'll move on to the reaching equilibrium. And I hope that you enjoy this. So let's start off with what are GANs. Eventually it's a very good question to ask for yourself. Anything you get, what is dash? Okay, if you have any kind of question, so what is GANs? I would like to define GANs as like this. GANs, we have two players and they always compete with each other. But in formal terms, I would say GANs are the framework of machine learning that consists of two players, which is generator and discriminator. But again, let's little bit put some weights over frameworks. So what do I mean by frameworks? It's very easy to understand what do I mean by frameworks. And the thing that I mean by frameworks, like in machine learning or in deep learning, you have natural language processing, or you have computer vision, or anything else domain. It can be an AI in medicine, and etc. So these are the domains of machine learning, and GANs are also the domain of machine learning, or the framework of machine learning. We can say, just like in Python, you have pandas, numpy, etc. So just like this, we have a GANs, and GANs consist of two trained neural networks. They are fully trained players. Let's remove neural networks from here. Let's write players. Okay, so they are two fully trained players, and the first one is generator, which is player number 1, and it's discriminator, player number 2. Okay, so what is the role of these two players? These two players' role is to train to generate the fake data that looks like real. And you may think, hey Yusham, I haven't got anything. So just listen me carefully what I'm trying to say you here. I'm trying to say you here that the generator over here is trained to generate the fake data, means fake example that looks like real. And its task is to fool the player number 2, and player number 2 is discriminator. Okay, so I've written the definition. What is this? It is trained to generate the fake data, but that looks like real, although the picture looks like real, but it's actually the fake. Okay, and it tries to fool the discriminator, which is here. Okay, so it always tries to fool, but how it fools? Discriminator is classifier. Discriminator is classifier that trained to classify fakes from the real. And here fakes denotes the fake example generated. All it looks like real, although it can generate a realistic example, but it tries to classify the generative example and from the real example. Okay. And another word is it tries to not be fooled by the generator, which is player number 1. Okay, so we have here, which is so we have a player number 2. Player number 1 tries to fool the discriminator, player number 2, and player number 2 tries to do not be fooled by the generator. And in what terms that they are fooled and do not be fooled? The generator tries to generate the fake data. What do we mean by fake data? Fake data means it generates the example that looks like real, but it's actually a fake now. And keep it simple, not keep it hard. It's very simple, okay? Do not keep it, because the main problem is of your, and any of them, we take the particular thing so hardly, but it's actually not. So don't think it is hard. Just understand what I'm saying. Generator is trained to generate the fake data that looks like real, because it always tries to fool the discriminator so that the discriminator classify generated example as real. Now generator 1, because they are a generated example, works best, and discriminator is always trying to classify the generated example and the real, and it will say it's 50% fake or 50% or maybe 90% fake. Okay, so in this way they do the competition. And what do I mean by competition? Competition means it's always tries to fool. It tries to do not be fooled. Do not be fooled, okay? And it tries to generate the fake data that looks like real, and it tries to classify it. It's just a classifier. That's just we have given a name, and in this way they compete. So that's why I've said that they are 2 players in the playground, fully trained. And in this way, they can, if generator is increasing, means if generator is generating more realistic, then discriminator has to also advance himself to be a more advanced classifier. Okay, and in this way they compete and they improve each other, and that's called the Minimax game, if you have seen that. But no worries, don't pull up the leg of Minimax. Okay, so in general, we have a generator goal is to generate the fake data from the real. So this goal is to generate the fake data that looks like real. And the second example is discriminator goal is to classify the example as a fake and a real, and there is all this competition between them. So generator tries to fool the discriminator, and discriminator do not be fooled by the generator. Okay, so it generates, and discriminator say, okay, this is a 50% fake, then it will make some more thing, and then like that. Okay, so let's come to the how they are trained and how generator generate example, how they learn, etc. So what to do, we just take an input vector z, so I will then denote as a noise vector z. It's just a random number. So here we have a 3-dimensional 3D array, or I can say the vector, or I can say the 3D vector. Okay, so we have a 3D vector, and the vector can be 100-dimensional also. The vector can be anything, but in this course we will mostly take in a 100-dimensional vector. Okay, so we take out a noise vector z, and then we give to the generator. A generator is neural network that will take this noise vector z and generate some random noise, just like this. Okay, let's denote as x star. And then we take out the real data. We do not show this real data to the generator. You may think, yeah, what are you telling? This is a real data that we will use to train, and we do not show this. We do not show this. We only give this real data and the fake data to the discriminator, and discriminator is just a classifier, so it gets real data and it gets fake data and classify this as a kind of a real and fake. And after that, we take out a classification error, which means how much our model predicted correct or wrong. Okay, this is just a J of data, as you have seen in your favorite cost function, which is J of data. Okay, and after that, what we do, we simply take out the gradient or a partial derivative of our cost function classification error with respect to discriminator, and then after what we are just taking out a partial derivative and partial Derivative is just it just tweaks the parameter. So what do you say? Let's say our bad theta that this parameter used to generate and classify. So these are parameters that let's say it previously was 2, and using that we are just generating example. Now it simply tweaks it. Now this after partial derivative just tweak, let's say 2.4. So 2.4, and it seems to be 2.4 works best. So 2.4 works best. Then it updates the theta to be not this, to be now this, and then it takes out a partial derivative with respect to generator, and then it just take out a partial derivative of a cost function and then update the weights of generator. Okay, and that's how all the training, and this is just a gradient descent if you have seen, but it has some it has 2 neural networks, and it's a simple, very simple. Keep it as very simple, and we do repeat for each iteration, We will see what we are doing. Okay, so we take our noise vector, we give to the generator, generates image, then we do not show this, we simply give to the real data to the discriminator, and discriminator classify it, then we take out a cost function, and then we update the thetas using the gradient of that cost function. Okay, so training of a discriminator. Let's summarize again. So we take out a real and the fake data, then we give to a discriminator, and then discriminator will classify it, and using that we simply update the theta by taking out a gradient of our cost function. And we always want to minimize this cost function, as is obvious that we want a good model. Okay, so what is generator? I mean, so training process of generator, we take out a random noise vector z, which can be any dimensional, which you want, and then you take, and then you give to generator, and generator generates some example, and then you take out a real data, and you do not show it to the generator. You only give to the discriminator, and then you take out the error, and then you update the weights of generator. Okay. But one thing that I want to notice here is a fun thing that here generator is we are biasing through discriminator. Generator is kind of in a bad condition. He has told to generate the example. He has told to paint something. Let's say player 1 has told to paint something. Okay, so but we haven't told to generator what to paint, and just imagine that you were told to paint something, and then he painted, let's say he painted noise vector, and anything bad image. Then we show it to the discriminator, which is a kind of an instructor of this. So it says no, it is bad. As it says, it is full, it is fake. Then it's make real, then etc. by updating the cosmos, etc. And actually generator reach out to that after 30, maybe 1,000 epochs. It generates the example the same that you want. Okay, so just imagine the goal is needed. Life is meaningless without your goal. But in case of generator, it is a little bit different. Okay, so what we do, we repeat for each iteration, and we do each of these. I mean, let's say in first iteration we do, however, we only simply change the parameter in first iteration. Then we do 1,000 iterations, so it will run 1,000 iterations. So 1,000 times thetas will be changed, or parameters will be changed, and then it's likely to be getting the good model. Okay, so what is reaching equilibrium? What is that? It's very simple to understand. In our regular neural network, we stop training when our validation error reaches at the point where neither the when our validation error start getting worse, means to avoid overfitting we are training so much, so we stop at that point. But what in GANs? They both have competitive nature. One network gets better and one network gets worse. Have I confused here? Yeah, I have confused a little bit, but it's very simple to understand. Let's say here you have player number 1, which is generating the kind of a realistic image, okay? But actually this fake image, realistic image. And then player number 2 classify, okay, this is a real. But actually discriminator is fooled by this player number 1, and player number 1 wants the competition. Okay, so player number 2 has failed, and it's getting worse. Okay, so it generates the realistic image that discriminator was not able to classify this. Let's say was able to classify this as a real, and if this classifies as a real, actually it's a fake, but here P1 means player number 1 won, and P2 player number 2 lose. So there are two certain criteria to be met. The first one is generator start producing fake example that looks like real. The second one is the discriminator start guessing the images or maybe the data to be randomly guesses whether a particular example is a real or fake. Okay, it's very simple to understand. Okay, so in summary, we have learned a lot, and I hope that you enjoyed this tutorial. In summary, we have two neural networks in GANs, generator, discriminator. They both have competitive nature. One tries to fool the discriminator by making a real example that looks like real. Other tries to do not be fooled by the generator. When we reach at a point whether a particular neural network and the other neural network, which is generator and discriminator, are not learning, so we stop at that point or are not improving. Okay? Okay, so I think that you have enjoyed this tutorial, and if you want PDF, you can comment down below. I will definitely take a look if you want the PDF. Okay, so thank you for seeing this video, and in the next video, one of my favorite first project, which is generation of fan clothes. Okay, so we will work on the live coding, fully theme based. I have taken Sublime Text with extra very good theme, so it will be good theme so that you can get a more coding like feeling, and then it will generate images. Fashion means clothes that I just wear. So I hope that you will carry out in my next video. Till then, I would highly recommend to complete this video again if you want. Otherwise, if you got it, is good to go. And a previous video, which is a deep learning video. Thank you for seeing this video. I'll be catching up in the next video. Till then, bye-bye.